Okay, so let's try to prove this problem. We have here our first proof for a rhombus. So we're going to go first with rhombuses, and then afterward we'll have one proof for a square. So let's say, for example, if a parallelogram is a rhombus, then it has diagonals that bisect opposite angles. Okay, let's say, for example, we have your rhombus INTS. We need to prove that NS, this diagonal here, bisects angles INT and angles INT and IST. Okay, so there you go. So you have your NS. Okay, so we have here NS, okay, and it bisects angles INT and angle IST. Okay, and we also have your TI, okay, that bisects angles NIS and NTS. So that means these angles 1 and 2 are congruent, 8 and 7 are congruent, 3 and 4 are congruent, and 6 and 5 are congruent. So those pairs of angles are congruent. We want to prove that using a two-column proof. And with our given here that we have a parallelogram that is a rhombus, if a parallelogram is a rhombus. Okay, so we're given here for our first statement, okay, number 1. So given rhombus INTS, okay, so we can write that as a given. Okay, number 1 given. And we can write here on the second statement. Okay, so we can write here on the second statement, number 2. Okay, number 2, that rhombus INTS is a parallelogram. Okay, and the reason for that, okay, so if it's a parallelogram, so the reason for that is because a rhombus is a parallelogram with 2 pairs of congruent with congruent sides, with 4 congruent sides. Okay, so those are some of the properties, one of the properties of a rhombus. Okay, and for our third statement, we can say here that IN is congruent to TS since it's a parallelogram, and NT is congruent to IS. Okay, so we can write here opposite sides of a rhombus, of a rhombus are congruent, because we've already established, or it's a property of a rhombus, that it has 4 congruent sides. Opposite sides of a rhombus are congruent. Okay, so we can write that here. Okay, and we can also state, so we can also state here on number 4, okay, that triangles, okay, INT, NTS, TSI, and SIN are isosceles triangles. So those are 4 isosceles triangles. So how did that happen? Because we have here this side is congruent to this side, and this side is congruent to this side. So we have here triangle INT. Okay, so those are congruent. NTS, those are congruent. TSI, those are congruent, and SIN, those are congruent. Okay, so we can write here for number 4, isosceles triangle theorem. Okay, because they are isosceles triangles. Okay, for our 5th statement, so since they are isosceles triangles, we can conclude here on number 5 that their base angles are congruent. Okay, since they are isosceles triangles, so we can say here that angles 8 and 3, angles 2 and 5, angles 7 and 4, and angles 8 and 3, 2 and 5, 7 and 4, and 1 and 6. So angles 1 and 6 are congruent. So those pairs of angles are congruent using, because the base angles of isosceles triangles are congruent. Okay, so they're congruent. Okay, so we can write this as our 5th proof. And for our sixth statement, we can say that triangles INT and IST are congruent, And also we can say that triangles NIS and IST. Oh, no, no, no. Wait. Triangle INT and TSI. Okay, so, or IST, okay? And triangle NTS. Okay, so this should be triangle NTS. Triangle NTS and NIS. Okay, NIS are congruent. And the reason for that, the reason for these two pairs of triangles having congruence, okay, the reason for that is simply the diagonals or the diagonals of a parallelogram. Okay, parallelogram create two congruent triangles. Okay, so that's going to be one of our reasons for that. Okay, for our seventh statement, we can say that. Okay, so for our seventh statement, we can say that. Okay, for number 7, we can say that angles 8 and 4. Okay, and also we have here angles 8 and 4. We have here angles 2 and 6, angles 3 and 7, and angles 5 and 1. 5 and 1 are congruent. So they're congruent because of CP, CTC. We've already established that the two pairs of triangles are congruent. Therefore, their corresponding parts must also be congruent. So CP, CTC. Okay, so guys, if you notice, we have here 8-3 and 8-4, 2-5 and 2-6, 7-4 and 3-7, and 1-6 and 5-1. Okay, so we can use the transitive property of congruence or equality to show that for number 8, angles 8 and 7, angles, okay, so what's here? Angles 5 and 6, 5 and 6. So what else? We have angles 3 and 4 and 6 and 5. So angles 3 and 4 and angles, okay, angles 3 and 4, and we also have angles 6 and 5. Okay, angles, oh wait, 5 and 6, 8 and 7, 3 and 4, angles 1 and 2. Okay, so angles 1 and 2 are congruent to each other, okay, using the transitive property of equality. Okay, so we can write that. Okay, so using the transitive property of equality. Okay, so we can write that here. Number 8. Okay, transitive property of congruence. And therefore we can write here at number 9. Okay, so number 9, we can write here that NS bisects angles INT and IST, and also we have TI bisects angles NIS and NTS. Okay, so the reason for that is so it can be a definition of a bisector. Okay, definition of a bisector, because you've already seen that angles 8 and 7 are congruent, angles 6 and 5 are congruent, angles 1 and 2 are congruent, and angles 3 and 4 are congruent. Therefore, we can say that through the definition of a bisector, NS and IT or TI are diagonals for this rhombus are the bisectors for this rhombus. And that's it. Okay, for our third proof, we have here the diagonals of rhombus of a rhombus of any rhombus are perpendicular. So for here we have rhombus STAR, rhombus star, and we want to prove that the diagonals here TR and SA are perpendicular. Okay, so using the properties of a rhombus, how can we prove that the diagonals TR and SA are perpendicular? So first we write here the given. Okay, so number 1, STAR is a rhombus. Okay, so that's a given. Okay, and number 2. Okay, so number 2, we can say here Okay, we can say here. Okay, so we can say here for number 2. Okay, we can say here for number 2 that if you see here line segment TB, okay, so our plan is to prove first that these two triangles here can be congruent to each other. Okay, so if you see here line segment TB, okay, so it can be congruent to itself. Is that right? So we can write here number 2. Okay, so let's write it here. Okay, so TB. Okay, so TB. Okay, TB is congruent to TB. Okay, so the reason for that is, okay, our reason is the reflexive property of congruence. And it follows also that TS is congruent to TA. Okay, number 3, TS is congruent to TA. Okay, since, okay, because, okay, so because all of the sides of a rhombus are congruent. Okay, so that's one of the properties. Okay, and also we can say here that SB is congruent to BA. Okay, so we can write that here for number 4. Okay, SB is congruent to BA. Line segment SB is congruent to BA. The reason for that is that it's because the diagonals, okay, the diagonals of a parallelogram are congruent. Okay, okay, the diagonals of parallelogram are, bisect each other. Okay, so they bisect each other. So that means SB, the line segment SB, is congruent to line segment BA because it's been bisected by this diagonal TR. Okay, and therefore for number 5 we can say here, okay, say here for number 5 that triangles TBS and TBA are congruent. Okay, and the reason for that, number 5, is the side. Okay, side triangle congruence postulate. Okay, so let's write here our 6. Okay, so we can say here also, since we've proven that the two triangles are congruent, we can say here for number 6 that angles SBT and ABT are congruent. Okay, so they're congruent because we've already established that the two triangles are congruent. Okay, so this is the 6th statement, and the reason for that is simply CPCTC, or the corresponding parts of congruent triangles are congruent. Okay, so we have here number 5, okay, number 5 and number 6. Okay, and then we can say that in number 7, okay, so we can say here at number 7 that, okay, we can say here, guys, for number 7 that angles, angles SBT and ABT are right angles. Okay, so what's the reason for that? If you remember, guys, the properties of a rhombus, okay, so the one that we discussed a while ago, so one of its properties is that their diagonals, the diagonals of a rhombus, meet at 90 degrees. Okay, so meet at 90 degrees. Okay, so that's one of the properties. Okay, so therefore we can say here, okay, we can say here for number 8, okay, we can see here for number 8 that the measure of angle SBT plus the measure of angle ABT is equal to 180 degrees. Okay, so the reason for that is the angle addition postulate. Okay, angle addition postulate. And since we've established that SBT and ABT are right angles and the sum of their angles is equal to 180 degrees, therefore we can conclude here at number 9, okay, that line segment TR is perpendicular to SA, okay, simply because, okay, so the reason for that is, okay, TR is perpendicular to SA. The reason for that is the definition of perpendicularity, because we've seen now that they are perpendicular lines.